This is our kitten, Ginger, one of them. Ginger. But she's not here. This is a math lesson I want to do. Wish I could do that. A little steeper. There we go. Okay, so what I want to talk to you about today is ratios and rates. Okay, I guess my little assistant helper will help me with the lesson. But, well, since she's sitting here, what if we just do this? Let's talk about a ratio and a rate. So rates and ratio, rates think over time, such as miles per hour, right? Miles per gallon, perhaps. But ratios are just basically this. They compare two items, okay? Let's say in this case of Ginger, we're going to compare number of legs to number of tails. So in the case of Ginger and her, oh, I meant to grab my, right, hold on, I'm coming right back. I gotta get my napkin. Just take time with Ginger there for a sec. Oh, baby. Okay. Oh, she left you. Oh, well, sorry. Okay, just for simplicity's sake, we're going to say the ratio of legs to tails. Okay. We also write rates and ratios like this with a colon. So legs to tail, or even with the word to, T-O. Okay, but let's do it here. Okay. So let's just tilt, since she's gone, I'll do that. Okay, good. So legs, number of legs is, right? And to tail, 4. It's a 4 to 1, 4 to 1 ratio, 4 to 1 ratio, 4 to 1 ratio. Does that make sense? You'll notice it's a fraction. So the reason that's kind of interesting because we can then manipulate the fractions to talk about percentages, talk about, or extrapolate and add it on to different types of problems and solutions. And so here's why this is partly on my mind is this idea of, and there's stuff that's going to matter to you in your life, but maybe not so much in the adult world, such as miles per gallon. Maybe you don't care about miles per gallon, but what if you had an electric scooter? You would then, right? Right. In that case, you'd say, you could travel a distance you could travel on your electric scooter because you wouldn't want to be trapped outside. I see a kid around my neighborhood riding an electric scooter. It goes really fast. Today's batteries, I guess they hold the charge longer. Okay, let's talk about, though, miles per gallon. Because this really is a big issue for the adult world because it's expensive. Gasoline, okay, prices are down right now, but it always is an expense. And then how much gallon or the mileage your car gets, or today's electrics. This is the electric vehicle market. So, and talk about the future of autonomous and electrics, but that's a whole sort of different way of going about things in terms of how you get the electricity into the car. Okay. But my friend had a problem this weekend. We went on a motorcycle ride, and he has a 3-gallon tank. Okay. 3-gallon tank. And he hasn't ridden this motorcycle in a while. He's done some work to it. He wasn't sure how far it could go. Well, we needed to go about 150 miles between our gas stop. And he wasn't sure how far he could go on a 3-gallon tank. So what would be important there is miles per gallon, right? How far you could go per gallon. So what happened? Okay. What happened? Well, we traveled 125 miles. Okay. Then he filled up his gas tank and he got 2.5 gallons of gas in it. And he filled it up. So let's talk about this for a minute. How much fuel was left in the tank after riding that far? In other words, before he got to the gas station and filled up this, how much fuel was left in the tank? Got that for a minute. How big is the tank? 3-gallon tank. Okay. He went that far. He put that much gas in to top it back off. So believe it or not, we sat social distance and had a conversation. He said, Pete, you're a 4th grade teacher. It's kind of funny. They do that to me course, he's an executive with some other big company, so it's like he does math all day long. Anyway, that's not the point. But we wanted to figure it out. So we got to thinking about it. It's like, well, here's what I decided to do. I decided to forget the decimal for a minute because what I want to do is I want to divide those miles up for this amount of gas to see how far he was getting. Okay, so come down here. I got space under. I'm going to say 125 miles for 25. Just ignore the decimal for a minute. How many times will 25 go into 125? Now that's a mental math problem. Okay, that's a mental math. So we're taking all those miles and we're going to divide them up for each gallon of gas-ish to see how far you can go in 1 gallon. That's the idea here. So 25 into 125. Now think quarters, dollars. Even if you don't have to do long division with double digits, but if you did, you're just looking at, hey, 25, it won't go into the 12, but it will go into 125. How many times? 5 times. Right? 5 times 25 is 125. Okay. But we do have a decimal in there. So we're going to put the decimal back in. This long division with decimals, you don't want to divide your divisor to have a decimal. So what you do is you move it over, make it a whole number. But the same goes on the dividend. You move it over to keep your place value. It's always place value lined up and put your decimal up. So we need a 0 in there to fill that spot. Okay. So 50, he's getting, which I thought was ridiculous. He's getting, we both thought it was ridiculous. He's got a KTM 450, 50 miles per gallon. 50 miles a gallon. Okay, now 50 miles a gallon. That's pretty awesome. My motorcycle gets close to that, but not quite 50. I think I really run around 48 miles a gallon. But I have a much bigger fuel tank. I have 5 gallons of gas, so I can actually go much further than he can. So now you start to say this is a ratio, 50 miles a gallon. If you needed to travel 200 miles, this is a unit rate, by the way, because it's 1 gallon. So let's say, here's where the equal sign, here's where the fractions come in. Let me just erase this and rewrite it like this. So you can see it's 50 miles per gallon. And now you can use this to solve and extrapolate other problems. Let's say you're going to need to go 200 miles. Now you're solving for X. Guess what? Guess who shows up? It's the magic 1. It's the magic 1. What do you do to a 50 to make it 200? Right? You're going to multiply by 4. So you're going to multiply your 1 gallon. And this tells us now, if we're going to travel 200 miles, we need 4 gallons of gas. Can he do that? It's going to have to either have a gas stop, right, or haul some extra fuel. Okay, so this is where rates and ratios are really cool. Let's say that number of correct, I often do this for you on a quiz. Number of correct over number possible. This is a ratio. We're comparing the correct to the number of possible. So if you had a quiz that had a 10, which we often do, 10 possible, and you got 8, this is 8 correct out of 10 possible. We can then convert that, right, into a grade or a score by saying 8 out of 10 is equivalent to how much out of 100? Again, magic 1. 80 out of 100, which is 80% per 100 is 80%. And 80% then could be, look at a grade scale and you could go there. So ratios and rates, you've actually been using them all the time. If you think about the thief, right? 2/3. Now, 2/3, what we know that's 2/3 of a, right? 2/3 of the whole, okay? But we could use that base knowledge to deal with rates and ratios, okay? So rates and ratios. You probably do this a lot during this time of social distancing, stay at home, but walking. Now, I know a lot of you have the fancy watches these days, right? That track your steps and track your miles and all that. I find that if I can go at this pace, I get a good workout and I cover a good distance, okay? 3 miles in an hour. That's a rate. That's a ratio, a rate of speed in this case. I'm walking 3 miles per hour. I like three too because it's a nice round number. And believe it or not, I even use this for field trips because I have to consider, well, hey, what's the fastest we're going to walk? What's my slowest group? Because that's the one I have to kind of calculate the distance on. And when we walk to Chico State, say, for example, 3 miles in an hour. And let's say that I'm going to go out and do a 4 hour loop, which I don't know about you guys, but Pembroke's have been doing quite a bit of that kind of stuff. I know many of you are. Magic one. We're solving for how far we went. Okay, so we multiply by 4 because what did you do on 1 to make a 4? You multiply by 4, so therefore you do the same in the numerator. Okay, so that's going to get me 12 miles. Now, you do want to consider in this kind of work um, uh, rest stops and so forth, so you might have to take that number down. I know that if you kind of track that, it's kind of fun on your bicycle. Now, I know I have friends that ride like 25 miles an hour kind of consistently, but let's say on your bicycle, you probably go more in the neighborhood of 10 miles per hour. I betcha. You could figure that out probably, again, with your fancy watches or maybe a cell phone, or maybe your parents can help you with that. And again, same kind of logic as, hey, what if I rode consistently for 3 hours? How far would you go? It's easy, right? 3 hours. Therefore, I've got a 30-mile distance. Shout to Durham and back anyway. Okay, so that's kind of the idea behind rates and ratios. They're just fractions. But we've been doing some measurement work too. And the idea behind measurement is saying, you might, again, extrapolate. Say if I've got, let's see, what would be a good example? $3 per foot of board, $3 a foot. You can see this in all kinds of ways. You can talk about bags of dirt for a planting box. Do you know I have a planting box? You see it before? It's a composting thing. It's kind of cool. Wait a minute. You calculated all the math on that. $3 a foot. Not a foot like your foot. Unless you're talking about your shoes. I don't know. You can't buy shoes for $3. And let's say you're going to buy, 20 feet of wood. Well, how much do you have to spend? Okay. So these kind of things are happening all the time in our lives. Some apply to you more, like the bicycle and the walking thing, more so. Or maybe it's what you eat. How much food you need for a certain amount of calories. Those are all kinds of things. We do all these calculations all the time. But it's basically, what's cool about this is that you already kind of know how to do it, because you set up ratios or fractions comparing one item to the other, and then you just use the magic one to rename and solve your problems. So in 20 feet, obviously I'm multiplying by 20. My magic one is 20 over 20. And therefore, that's going to cost us $60. Okay? So you could do that kind of stuff for your parents probably, in terms of problem solving different types of mathematical equations around the household, if you know what I mean. Like, for example, how much do you spend if you go and have takeout per day? How many days in a week? How many times do you do that? All these different things. It's all life around you. I've got some kids are like sending me chats. I don't know if it's Caitlin. I don't know what they even say. You want me to read them to you? Doesn't matter. I'll check in with you. You guys see my shirt? It's one of my favorite shirts, man. Look at it. Look at it. Look at it. Look at it. John Muir. All right. See, that's that miles per hour thing when you're hiking. How much water you got to bring, any snacks. There's a good snack. I like the jerky. What'd you call me? I'm just kidding. Okay. Have a great day. We will catch you later. In about 2 hours per day. How much work you doing? 3 hours per day? How many words do you read? Ooh, how about your math facts? How you doing there? You're getting faster. See you later.